All right, we are on. Hello, everyone. Hey, everyone. Thank you so much for joining me today. It's Saturday, May 1st, and we have a special live with Atomic Six. We have a lot of guests, a lot of exciting stories, and we're going to be talking startups, space, composites, and all of these cool things. Before we get started with everyone, let's go ahead and say a couple of wait a couple of seconds to make sure that if you can hear this, go ahead, press a comment, do something just so that we can confirm that we can hear you and everything is working well. Okay, so we are streaming. I see already comments coming to us from Dr. Gohil. I see comments coming to us from Otenkaya. So, by the way, Trevor, Hisham, Doug, and Adam, just to let you know, this is perhaps going to be the most international experience you ever had because folks that follow me, having lived on three different continents, I have folks from all over the world, and we're gonna have a lot of fun time together. So let's go ahead and get started. Trevor, I'm gonna start with you. So you are, how are you doing, Trevor?
Well, I've got my Formula One shirt on today, and my boy didn't get on pole, Max Verstappen. I know you're a Formula One fan, but I think he got third. So, spoiler alert if you're watching live and haven't checked. Sorry about that.
Should not be doing that, Trevor. That's not a good start.
You say spoiler alert, and then you say the news, right? I got that backwards.
All right, awesome. Trevor, you're the president and the CEO of Atomic Six. In your
Yes.
bio, you put, I had zero experience in composites until 3 years ago. So, from zero experience to where you are today, the president and CEO of Atomic Six, tell us a little bit.
I think the most memorable first phone call I got, you guys know Continuous Composites. So Tyler Alvarado, good guy. They're doing some pretty cool things with 3D printing. He during the hour-long call, and this was probably, I think it was right before we met Hisham. He asked me what fiber volumes we were hitting, and I paused and I said, Tyler, I don't know what that is. And then I quickly realized I was very much in over my head and started to build my own composites research center using Google and many late nights and bothering Hisham with many dumb questions that he was so very nice to answer. So now I don't know that I'm a composite expert, but I feel like I can hold my own on a one-on-one level.
All right, so you actually, your passion is everything that goes fast. So composites, aircrafts, Formula One. So here you have a good match. And talking about things that go fast, Major General Doug, how are we doing?
Good, Ramey. It's good to be on the show with you and your entire audience.
Should I start by saying that it's fascinating the fact that you hold the world record for the fastest non-stop flight in a B-1 bomber around the world. Let's start with that. Talk to us a little bit more about that. How much time it took? What is it about? How do you get to have a world record and such a cool, fascinating thing?
Well, let's start with the easy part. It's 36 hours, 13 minutes, 36 seconds. So if anybody wants to log 21,000 air miles, that's about how long it's going to take to go around the globe. Uh, the fun part about the world record itself, and I teach this a lot about innovation and why it's fun to be a part of the Air Force Association, and particularly with Atomic Six, is I found that innovation always starts with no, and then followed up by a no. And eventually, when somebody convinces you that the good idea can actually happen, then you say yes. And in fact, that's what actually happened with the around the world record. And by the way, today, the person I was saying no to was a young captain in the Air Force at the time. He is now a congressman from the 2nd District of Utah over here on Capitol Hill here in Washington, D.C. And I'm really glad I said yes, and let's demonstrate the ultimate global power mission.
That is fascinating, and that is cool. and I know that your resume is. I mean, I picked the thing that is the dearest to my heart, but you are the executive vice president for the Air Force Association, on the board of directors of Predasar. You were responsible for more than $10 billion of U.S. Air Force business. I mean, this is phenomenal, and it's an honor to have you on this chat today. Adam, how are we doing?
Doing fantastic over here.
Awesome. So we've settled that you are on planet Earth right now. Is that correct?
Yes.
All right.
It's hard to prove
Awesome. Talking
otherwise.
to us from planet Earth. So Adam, you're the principal at Starburst Aerospace for the U.S. Accelerator. Talk to us a little bit about this. What is Starburst Aerospace? What does it mean being principal there?
Yeah, Starburst Aerospace is a fantastic organization that specializes in making connections between all the parts of the ecosystem of aerospace and defense. What I do over here at the Accelerator program is that I help startups make those connections with defense primes and government agencies to get the business accelerated to the place that they need to be in order to do their next fundraise. It's a lot of fun. I see a lot of great ideas, a lot of fantastic people, and have a good time doing it too.
This is awesome. So your BA is in anthropology, and
yes, it is.
So this is fascinating, and you connect that to astronaut training and selection programs and so on. Talk to us a little bit. Like, I mean, I used to teach ergonomics at the university, and
Very good.
like anthropometry, and these elements are part of it, and the astronaut position and all of these things. Talk to us a little bit. Where are we with this domain right now?
Sure. Well, astronaut training and selection programs was a microcosm of the broader concept of the relationship between people and the technology that they create. And I was fascinated in sort of what the conception of science is in the public domain in the United States and in the federal sector. And that stuff really motivated my move into DARPA, into the DoD, and also a year on Capitol Hill doing advocacy for advanced technological mitigation strategies for climate change. Technology and humans, are in some ways the two sides of the same coin. Humans and the things that they make are extremely interrelated. And I was curious on how to make those things happen faster and in what sort of ways they rub up against each other. I can talk for ages about the dual friction between wanting to move faster and having stability, and that being true in federal government programs and astronaut training selection programs, just the same.
That is the core of almost everything. So this is my daily struggle, because I do hold a position in industry and a position in academia, and what you just defined is like the struggle between the race within industry versus how it happens in academia. This is phenomenal. Hisham, how are we doing?
Doing great. How are you?
Fellow Lebanese.
Oh yeah.
So Hisham, besides your killer Arak drink that you make, which perhaps we're gonna talk about the recipe a little bit. You're the CEO of Endeavor Composites. You're the chief scientific officers of Atomic 6. Tell us a little bit, like how do you manage?
Sleep is overrated. Don't sleep. But the benefit of being in a startup, we're not as overloaded as a big corporation, so it was a bit manageable. Thank God Trevor is a quick study. He was able to reduce the load of my shoulders. We've been growing both teams together and sharing experience from business side and science side. And it made sense that he leads Atomic 6. It's what they do is a complement to what we do at Endeavor. So we were able to continue the story there. At Endeavor, we create fabrics, non-woven fabrics specifically, and functional composites. And Atomic 6 create more the structural parts through their proprietary autoclave process. So that
Cool, which
those two became a good two pieces of the puzzle, creating a beautiful picture of composites, taking it from cradle to cradle in a way, and having a full circular picture of composites. And working with a happy team, with a motivated team, is always make life easier. We share the load, as I said earlier, and that help us progress further. And that's how I was able to manage.
That's good. This is very important. Stability in a team and the ability to give are crucial and fundamental for anything to progress.
And one
Major
thing I would
General,
like
let's
to
start.
add,
Say again.
one last thing I'd like to add to the audience. If you want to be an entrepreneur, the 8 to 5, you have to forget it. There is no 8 to 5. There is like you just work and it just happens. So you have
Okay,
to.
I'm gonna take it to the next level. I don't think it's only for entrepreneur. I think the concept
No,
of
most of them. Yeah, you have to give
the concept of 8 to 5 is actually a harmful concept for so many reasons. I mean, people need to achieve what we call work-life harmony, not work-life balance, and find a way where, you know what, you come back home from a nice dinner with friends and so on, and you work for an hour, like without stressing yourself on this, and make sure you are delivering. That's the right way. I mean, this is my own personal philosophy. You find a certain harmony that works for you, and don't stress out, because Hisham, even an engineer who is starting today, if they go to their work 8 to 5, how are they gonna manage to progress and move to the next level and so on and so on? So not only an entrepreneur, I believe passion has to find its own balance. But that's not the topic du jour. So,
No.
Major General Doug, I'm gonna start with you with a question. How do you see composites playing a role in the next generation aircraft the US will need to stay ahead of the competition? Or, what are your thoughts on this? And a side question, all these cool aircrafts behind you, tell us a little bit about them.
Okay, I'm going to have to take this in bits because
Go ahead.
everybody's wondering, why am I on here? Well, I think it's important because working with Trevor and Adam and Hisham, I think the simple answer to your question is the innovators, the startups are a national imperative now. And for example, we at Air Force Association, and particularly myself, recognize that we have to support small to medium businesses, the real brain trust of our nation. And I'm being very candid about this because if you look historically, and I previously worked with Northrop Grumman, and through my time there, after the Air Force, I began to realize that a lot of the companies today are really a result of mergers and acquisitions. Many of them, in fact, Northrop Grumman, for example, is well over 170 mergers and acquisitions over probably 30 to 40 year period. But why I bring that up is because in the end, you can only have so much research and development in each of these companies that exist today. What has fallen on the floor is really the entrepreneurial spirit. And I'm so excited because, Rami, you're having a show about entrepreneur, about composites particularly, and how it's going to really fit in our national imperative. That's why Atomic 6 represents everything that we at AFA want to support. Now, let me get to the war.
Look at the smile of Trevor. Look at the smile of Trevor.
We're recording this, right? We got that on record. We can quote it.
It is live. It is live. It is recorded.
And the reason why I laid these airplane out is because I know your audience doesn't necessarily have degrees in aeronautical engineering like I do, or some super doctorate like Hisham and Trevor, who's now become an expert in composites and still trying to spell Atomic 6. But yeah, the first thing I asked him was, "What does that mean?" He says, "Well, it's the C for carbon on the element chart." Unfortunately, I didn't pass chemistry too well, so sorry, Trevor. But if you look at the generation of airplanes on my desk, from the all metal constructed airplane of World War II, the bomber, the B-29, to right here, this one. And then you go to the B-1 bomber, which was let's say mainly still more metal built, to eventually to the stealth bomber, the B-2 Spirit. the technology of composites is resident in this revolutionary aircraft that is representative of stealth. And that is an incredible game changer. What I'm seeing now, and the reason why I joined the board of advisors, and it wasn't hard for Trevor to recruit me, is because what we're doing is we're now taking to the next phase, because eventually you're going to have the next generation fighter, next generation bomber, but the composites are actually lighter, stronger than steel or aluminum that was put in a lot of these airplanes of the past that I used to fly until I flew the B-2. I'll give a lesson on aeronautics a little bit later, Ramey, but let's just say that you take that technology that's in the B-2 today and you up your game to the B-21s, of tomorrow, which is the next generation bomber, or you put it into the next generation satellite system, and that thing's traveling at 17,500 miles an hour. Super game changer. And that's why I like Adam, because what Adam's job to do is really kick people to really push those capabilities even further and in a creative way, to where blended body technologies, super fast cars, the things that are going to be more autonomous of tomorrow are really going to be composite. But they got to be lighter and more capable for our nations, not only for our national security, but also just for our commerce. So let me stop there, because I do have a war story that I'm going to kind of treat you with on how strong is composite compared to steel. Back to you, Ramey.
I mean, I believe in everything that you said, and thank you so much for it. This is what I say to my students in the classroom. I want to give a shout out to Amalek from Orbital Composites. He's next to you, Adam, in California.
Nice.
Big shout to him. He hired one of my students last year, Anil, and I think he's doing more than phenomenal. So shout out to Amalek.
Hey, Rami.
Yes.
So if we've got composite folks at Orbital, I got a plug. I'm flying to LA on Sunday night. I will be there all week. My schedule is filling up, but Orbital's not on that schedule yet. Adam has been so helpful in helping me fill that schedule up, and General Rayberg put me in touch with the SpaceWorks guys, so I'm meeting them on Monday. But Orbital, if you're still listening, I would love to reach out to you guys and meet you while I'm in town this coming week.
So you can later. I'll give you the link to the whole experience, and you can see the folks that are commenting, and you can click on them, connect, and take it from there to the next level. You see, that's why I call my research team neXt, the next level.
There it is.
Awesome. Adam, question to you: how have you seen material science and hard tech company startups succeeding in this new race for space?
Yeah, I wanted to connect this to Rayberg's point about the broad applicability of materials science. How do you make an airplane go faster? Software and efficiency control systems can only squeeze out percentage points of efficiencies. If you really want to make something go much faster, you have to do design changes and you have to do materials changes. And the materials changes is the efficiencies, or is the game changers rather than the efficiencies that are needed to make that happen. And that's what's great about composites, and that's what's great about Atomic 6, that these composites are the only are the primary thing that you must invest in order to get next level performance out. What's really cool about materials science and materials startups is that they're uniquely applicable to immediately a broad set of markets. Trevor's technology in Atomic 6 is so good, there's nothing you can't make out of carbon composites. The traction that they're getting in the aerospace industry, the traction that they're getting in the logistics industry with trucks and trains is a testament to how much of a societal shift the innovations they're making over there at Atomic 6 are going to bring to fruition. In terms of what these companies are doing to succeed in the race to space, right? The ease of access to the low Earth orbit environment and beyond because of decreasing launch costs, is making it so that there's a lot more interest in investing in interesting ideas in space, seeing what works, seeing what doesn't work. And so there's a lot of companies spurring up that are bringing these ideas to the market and seeing if they can get invested. What is interesting there is like, what does success mean? Missions in space as success, technical success, business success, venture capital success. All of these are quite different and sort of could warrant a discussion on their own. But the race is on and the market is hot. So the time is now.
That's a good one. The race is on. So with what you just mentioned, what's the best way for a company? Like, I mean, there is a lot of aerospace companies listening to us today. What's the best way for a company to be involved with the Starburst accelerator?
Absolutely. So at Starburst, if you're an aerospace company who's trying to break into the ecosystem and trying to get these customers faster and have these conversations with defense primes, you are at the right time to join the Starburst accelerator. You can join by either going to our website, starburst.aero, and applying online there, or emailing me at adam@starburst.aero.
Here you go. And for everyone, I'm gonna go ahead and edit the description at the start later if you're seeing this video at a later time, and I'm gonna go ahead and tag Adam, Trevor, Hisham, and Doug so that you can add them on LinkedIn and take the communication to the next level with them. Hisham, I have a question for you. So there is a lot of collaboration between Atomic 6 and the Oak Ridge National Lab, obviously, that you are partnering with that. How are they trying to help Atomic 6 accelerate composite technology in the US?
In general, Oak Ridge National Lab is the biggest material and composite laboratory that the Department of Energy ecosystem have. They've been always leaders and pioneers in this area, from reducing the cost of carbon fiber, advancing additive manufacturing, advancing other techniques of advanced composite manufacturing. They are the headquarters of the IACME, the Institute of Advanced Composite Manufacturing Innovation. And they have been working a lot with different startups, including Atomic 6 and Endeavor and many others, because they believe in the they believe in the mission of innovation, and they understand what this innovation will bring to the American manufacturing and the benefit in the long run that will affect creating jobs and keeping us on the cutting edge of the state of the art. So they've been very welcoming, especially for reasonable scientific discussions. They've been helping through collaboration. It's known as a CRADA in the government federal world. And they initiate a lot of different CRADAs. Sometimes they even have user facilities where companies can get access to very expensive equipment that normal business won't have and don't need to invest in it because we use it twice a year. So the government have been very, very supportive in allowing us this access and tapping into their brain power and engineering power for improving our work and validating our work to better serve the American society.
Hisham, what is I maximize the screen on you, and on the left I see I don't know what I see, the poster on the left.
That was actually a Christmas gift from Trevor. It's the Space Shuttle Endeavor on top of the Boeing plane taking it to California.
Good one, Trevor. Good one, Trevor.
Yes.
Where was my Christmas gift? What's going on here?
Well, my company is called Endeavor. Hopefully soon we'll find a niche for you and we'll send you one. But I'm obsessed with the space shuttle, especially in 2011 when I was doing my master's. We were selected as part of the students-funded projects funded by NASA to go on a special tour. So shout out to NASA. I was with the group that walked through the processing.
Big shout out to NASA.
Yeah.
Huge shout out to NASA.
And we got to see Space Shuttle Endeavor up close, walk around it, through it, and we went as well to the vehicle assembly bay. They gave us the super VIP tour there, and since then I've been obsessed with the space shuttle endeavor.
Hisham, they knew that you make killer arak, and they were trying to lure you somehow. So
I don't know how much the government would like that, but
awesome. Big shout out to NASA. I have 30-40 collaborators over there, and very honestly, the kindest, smartest people I've ever met. Big shout out to NASA. So Trevor, I'm going to ask you a question. What's the biggest obstacle you have seen for hard tech material science startup companies in the aerospace and defense industry?
I think the biggest, well, I think there are two really kind of equal obstacles. The first is when you like watch the show Shark Tank, or you hear about some company on TechCrunch, they wrote, you know, this new software code, and within 18 months they're revenue generating, and it's super scalable. But, you know, some other smart person could probably like rewrite that code or copy them, so there's not so much defensibility, but you can get off the ground pretty quickly with just some friends and a long weekend and write some really unique software. But with us at Atomic 6 and even Endeavor and a lot of the other hard science material, hard tech companies, it's really difficult to get people behind you. And so if you can bootstrap yourself high enough to a point where you get some momentum and you kind of start that flywheel, that's really like the key to a success for hard material science. But again, it takes, you know, 12, 24, 36 months versus, hey, me and my buddies are going to write some code over a few months and be successful. So, you know, Hisham can attest to this, but our very first trip, I love this story here. Our very first company road trip, we got invited to Wright-Patterson Air Force Base, which is in Dayton, Ohio. We worked alongside the Air Force Research Lab and the University of Dayton Research Institute. And so I go, hey, we've got this new technology. We can do these really quick cycle times. So we took enough material to do, I think we were planning on 4 or 5 panels the very first day. It didn't work out that way, as Hisham can attest, but it's hard science. And so things go wrong, and you can count on things going wrong. You actually count on things not going right. And you just have to keep iterating and keep inventing and progressing that process. So with hard science, it's difficult, but luckily there are entities and companies and programs like AFWorks, which is through the Air Force, or the SBIR, Small Business Innovation Research, or the STTR, which we're involved with you, Rami, small transfer technology. I forget what the name is, but we've got a program with the University of South Carolina for the STTR. We've been awarded a phase 1 for that, so we're actually under contract. The government is paying us to do some research there, as well as the SBIR side. So we're actually now submitting phase 2s. So for a phase 1, I think we got a $50,000 check per phase 1. And that's more of like hey, it's a customer discovery, figure out who you need to talk to, where does your solution fit within the US government? And so just getting a $50,000 check for a startup who, like, I funded it from my Amex card, that's a huge deal for us. So like just getting a phase 1 is great. And they pay you to do customer discovery. So the phase 2 is actually a $750,000 research grant. And so over a period of 15 months, assuming we are awarded it, and we're actually submitting for 2, we've got the Space Vehicles Directorate backing us on the STTR program that we're doing with the University of South Carolina. We'll be making some composite support beams on solar arrays. This stuff's going to space. It's going to be really exciting. The other one we're actually doing with the Air Force.
Exciting. And
yeah.
Shout out to Alex, who's been a tremendous support on all of this, Alex Brasington.
Yeah, thank you, Alex, for helping us.
There's nothing you can't make out of composites.
I'm going to take this snippet and play it on repeat in my class.
Yeah. But yeah, just those 2 programs. So getting the government funding, getting enough traction to where you can get the attention of someone within if you can show dual use, and that is key. You can't just be straight defense. You've got to be dual use. Luckily, in our case, we have almost infinite uses. So composites, we do talk a lot about carbon fiber, but our process is agnostic to fiber. So we've made a ballistic panel with 3D woven e-glass, totally different than the carbon fiber. And then the resin systems, we actually did a thermoplastic resin system with the 3D woven e-glass versus your aerospace grade carbon fiber epoxy thermoset resin system. So our process is agnostic to both, but if you can get enough traction behind you and show the dual use technology for your solution, the government will get behind you. And it's not that difficult to get into a phase one. I do recommend hiring some help. We did so. And shout out to Michael Kunkler and Virginia Falls Technology. They helped us do some submission work and continue to help us. So it's one of the best bang for the bucks. And also Major General Rayberg shaking the tree, as I like to say, and getting us some letters of support. But it's, it's a team effort. And so once that flywheel starts going, that's the key for any startup. Get the flywheel going. If you can bootstrap yourself, the longer you can do it, pull in some government funding, pull in some friends. Getting Starburst behind us was so massive, and I didn't understand how big that was. So I was listening to a podcast, Francois, their CEO, he said, and they're a global entity, the one and only global aerospace entity in the world for an accelerator for aerospace companies. They look around about 3,000 companies a year, and globally they take in 20, give or take. I think they're bringing in some more this year, but 10 in the US, and Atomic 6 happened to be one of them. And I am freaking floored that we were in. And the Starburst crew has been instrumental. I mean, we're on the Slack channel like every hour talking and texting. And so bringing a crew, like a great board of advisors, like General Rayberg, and then having the Starburst behind us, it's really helped take some of the workload off that getting off the ground. So that's my suggestion to material science hard tech startups.
Awesome.
Trevor is one of the best. The material science pathway that he described is definitely the way that you want to do it. Material science versus software, there's that scaling issue, but there is also some benefits, right? Every day that he goes by developing that technology and working at these kinks is moat that he's building to make sure that he's building a resilient business. And Starburst, we're lucky to have him.
This is awesome.
If you don't mind, let me jump on to Adam's point and go back to the original question you asked me, Rami. It's about the need for speed, as we call it. You probably got one of the few people on the screen that's ever flown twice the speed of sound. And I never told Trevor this, but the most important part about composites is recognizing the end user, the one that's actually going to put it into application or put their life on the line. So when you're flying at, let's say, 600 to 700 miles an hour at about 400 feet off the ground, one of the challenges is that the aircraft begins to heat up because of the friction. And that's one of the problems I experienced in the F-111. Flying at that speed, there was literally a clock that started when the skin temperature of the aircraft exceeded 130 degrees centigrade. And imagine what it'd be like if I'd been flying an all-composite fighter. That probably would not have been a problem. So there's one more story down, and I got a few more to go. But
I want to hear actually a couple more. That was my next thing. And I mean, you have flown the B-1 bomber, and I'm sure there are more stories. Is there anything else you can share with us? Because us scientists, I mean, and we do the things, and we do, and at the end of the day, you're like the users are really who are in control of, okay, this is good or this is bad, and your experience is phenomenal. I mean, flying twice higher than this is just phenomenal. I would love, and I think everyone else that's listening to us would love to hear a couple more stories. So share something else with us.
Yeah, again, it seems like Adam and Trevor, Hisham, we're clicking here, guys. So there, believe it or not, there is something that I want your students and those that really understand composites to kind of perk their ears up on. And believe it or not, it has to do with this B2 behind my back. Believe it or not, 2 weeks into my job as the commander of Whiteman Air Force Base in Missouri, the illustrious 509th Bomb Wing. Believe it or not, we dropped, no kidding, floor.
I think we lost a little bit.
Because he's dropping classified information.
Okay. Now that I've set the
Major General, I think your internet dropped.
The most important part dropped out.
It's so actually interesting because
Let me try
you were saying we dropped and your internet dropped for a second. So if you want to take if you want to go back from where we dropped.
Believe it or not, due to a maintenance problem, one of the right landing gear actually, or the left landing gear, collapsed and folded up on the ground, and the airplane left wingtip. And as everybody knows, the wing, it's a flying wing. So the wing hits the ground. And the lucky part is that the wheel well door, the landing gear door, which is all composite, took the blow on the floor.
Wow.
Followed by the bomb bay door, which was also open. And it's a little hard to describe, but let's just say these doors, if you're just standing up, are about chest high or higher in terms of length. So immediately the landing gear door cracked, but broke the fall, and then it broke, and the entire 350,000 pounds of pressure were now sitting on one bomb bay door, which is, the doors that open and close in the classic. And now I had 350,000 pounds of jet sitting on an all composite, well-designed, strong door. Now, imagine what that's like when you don't know how long that's going to last until you get the airbags underneath, blow the airplane up, and then you go spend a few months repairing an airplane. But it's what Adam said is
just to let you know that last 5 minutes is how I'm opening my class when I'm talking next. Like, I'm gonna take these 5 minutes and I'm gonna be like, silence and listen. I'll put it and then let's talk about it, because you said a good sentence there that's so important. You said a well designed. So we connect the world of design with the world of material, with the world of all of this, and this is just phenomenal.
Well, let me add a little bit more intrigue to this.
Go for it.
We'll put it all together. Imagine a door that's thin, not thick. So a lot of people have in their mind that this door must be really thick. It is not, because some of the technologies that were built then really called for a light door that's really, again, it's the composites. I can only imagine the technologies today and the strength. So now I've brought two things into the dimension of this conversation, which I'm going to hand back to my team here. And that is, think about controlling temperature or being able to go faster and hotter, as well as to be able to have the strength. And then I'll add more to the ability to have a lighter structure, which is going to make a totally difference, because what I want to talk about in the future is hypersonics. Think about going 5, 6, 7 times the speed of sound. Now you put in weight, heat, 10 times the speed of sound. And you're talking about going from Adam's house there in the LA area and all the way and hitting a target, let's say in China, that you got to hit in 30 minutes or less. That's a whole game changer. That's a whole new world. Or take travel around the globe and somebody in an all composite structured airplane and going from coast to coast in maybe 45 minutes to an hour at most. So think about that for a moment. That's
crazy. This is really the next generation. So Trevor, the time is upon us. We planned for approximately 30 minutes. We've been on for 40 minutes now, which is super cool. I want to say that we've had 180 folks listening to us, which is neat. And I want to make a round before before we wrap up, like one by one, and I'll end up with you, Trevor, to tell us a little bit about what's next for Atomic Six. Where do you want to go? Where do you want to go next? Hisham, let me start with you. What's next for Endeavor, the partnership with Atomic Six? What's next in the world of science?
Oh yeah, so first of all, I want to say thank you for all those who took the time to watch us today and listen. Next for us, we're scaling up our nonwoven technology so we can meet up with the industrial supply. And as well, we're expanding our work more and more to serve the hypersonic area with functional composites. And that loops back to the collaboration with Atomic Six, where this functional material we're making can become a composite through their state-of-the-art technology.
This is awesome. Thank you so much, Hisham. Adam.
Thank you.
Yeah, what's next for Starburst is we're growing our network and we're growing our team. We're looking for good people to join us on the accelerator side of things, absolutely, and looking for companies and stakeholders to join in on the conversation to make great people like Trevor with Atomic Six go to market faster and get their solutions in the field where they need to go with Major General Rayburn.
Thank you so much, Adam. Major General.
First of all, thank you to your audience, Rami, and I too personally want to shout out to Air Force Acquisition and specifically the Air Force Research Lab and the Space Command, our newly formed single service, in what they're doing in terms of number one, the same thing we do at the Air Force Association is support and accelerate innovation, startup companies, the technologies, and actually merge the venture capitalists with the equity, with the great minds of the world. Let me end with this one. In September, middle of September, look for the Aerospace and Cyber Conference sponsored by the Air Force Association. If you really want to get into and expand on this conversation, please join us for that in September.
Is it going to be a face-to-face conference or is it going to be a virtual?
Live, virtual, and constructive.
Awesome. Cool. Thank you so much, Major General. Trevor, you brought all of us together. The last word is for you. What's next for Atomic Six?
For Atomic Six, so I just signed the lease for I haven't said this publicly, but we just signed the lease for our very first facility. I signed it yesterday. Took a little picture in the warehouse with a signed document, so thank you. I sent Hisham the picture. I said, we got some work to do now. Now the real work. Robbie, the crazy thing, all the data and the insane performances we've hit have all been done on someone's borrowed equipment that's not actually designed for our process. So all the great performance metrics and the things we've done, we're gonna be improving upon that once we get our own roof over our head. So yeah, it's exciting. And actually, if you roll up the warehouse doors, you can literally watch fighter jets land at Dobbins Air Force Base. So we are super pumped about that. I'm sure we'll be watching the president whenever they fly into Atlanta, come in on Air Force One, land at Dobbins. And so we're actually in the middle of our funding round. So Starburst is helping make introductions to VCs, angel investors, any folks like that are listening. It's May 1st. You've got about 3 weeks left. Our round closes, but we currently have just over a 3-year runway with the amount of money that we've raised. But if you are interested, reach out. We are still taking some investment money. And then the next step, I'm flying to LA on Sunday and we're continuing to speed up the flywheel. So we've got meetings with all sorts of defense primes, launcher companies, satellite companies, SpaceWorks. It's going to be a very, very busy next week, but we hope to have the facility up and running and operational early June. And we will be having our investor and board meeting, board of advisors party in late June at the warehouse. So Rami, if you're available, please come on down and join us.
I'll definitely plan to. Thank you so much, everyone, Adam, Doug, Hisham, and Trevor. Thank you so much. It's been fun. And till the next time, and all the best for all of you. And we stay in touch. Bye, everyone.
Bye. Have a
Yeah.
good day.
Bye.
Thank you so much for listening for another next live. This was the first time we go live since December. We're gonna try to do that from every so often on the weekends. Thank you so much. Stay safe wherever you are, and all the best.